our Coastal Landscapes unit. It's a very short lesson. And it's about the 4 main types of erosion. Now remember, you will have seen this before in GCSE geography, and I know from the people that have been in class that they remembered a lot of these, but just to make sure that you are fully aware of these 4 types of erosion, I'm going to do a short video on that. So remember that we have landforms generally speaking associated with erosion, so we see some stumps and stacks here, some arches, and a cave forming here and a crack. These are all kind of the main features of erosion really. And then in contrast, which we'll come on to later, we have some landforms of deposition, so obviously you'll recognise straight away that this is a spit. So remember that the rates of erosion, never mind what type of erosion, remember that the rates of erosion are dependent on other factors. So the rock type, obviously, which we talked about in an earlier lesson, so more resistant rocks like chalk and limestone erode more slowly. Clays and sands are weaker rocks that are less structured, and the actual rock itself is less strong, so it's more eroded easily. So remember, we'd have a less steep cliff profile with mudslides and slumping if this occurred. So we've got hard rock here, chalk rocks here, producing steep vertical cliffs. And on the right here, we've got some, looks like a sandstone type of cliff, or a clay perhaps, that has got a kind of quite a shallow angle there because the cliffs have slumped down. Remember also, it's not just the rock type, it's also the lithology, i.e. the structure of the rocks. So if you have concordant rocks, as we know from Lulworth Cove, we get straighter coastlines, generally speaking. Obviously, Lulworth Cove has softer bands of rock behind, so we have that classic sort of hole shape in the cliff. But discordant coastlines generally, where we have the rocks running perpendicular to the sea, we have headlands and bays, generally speaking. So if you remember from GCSE geography, the 4 main types of erosion are hydraulic action, corrosion, abrasion and attrition. And remember also that abrasion can be called corrasion. If you remember, there are 2 words that can be used for that. Hydraulic action and abrasion really are the main 2 types of erosion that occur with destructive waves. Corrosion doesn't really need so much to have destructive waves, because remember, corrosion is to do with the chemistry of the sea being in contact with rocks that are alkaline. So it's a kind of different factor, but hydraulic action and abrasion in particular are to do with the power of the waves. But also remember that despite the rock type and lithology, which we've mentioned here, the lithology here, remember that also the effectiveness of erosion is also determined by these other factors. So is the wave big? Has it got a big fetch? Is it a destructive wave? The tide level. At high tide, clearly there is going to be more chance for the waves to erode the coastline than at a low tide, where it might not even reach the cliff. It might only reach a beach perhaps, or other feature on the coastline. The shape of the coastline as well. Remember that that waves refract around headlands, so we have greater erosion concentrated at headlands. So if you have a headland and bay type coastline, you will have stronger erosion occurring at the sticky outy bits, i.e. the headlands. So here are the 4 main types of erosion summarised, which you can read in your own time. There's no point me reading those out to you. Just remember that you've learnt them. So we've got the other name here for corrosion is solution, so there's 2 names for that as well. This is the kind of action of all those things together. So we have a wave cut platform here, which the waves have eroded basically away, softer material on the top here of this harder rock underneath. The waves continue to erode at the cliff base, whether they're doing it by hydraulic action or abrasion or attrition or solution. They're eroding a wave cut notch here at the base of the cliff. Eventually, the overhanging part of the cliff is too heavy and too unstable to maintain its position, so it collapses onto the wave cut platform. When the waves are big enough, the sea will take these rocks and pebbles out to sea. If they're very big, it obviously won't take them. They will be there, and you'll see the rubble strewn onto the coastline. So over time, you can see that the cliff will retreat because we've got we've got the waves continuing to act at the base of the cliff as the cliff retreats. Don't forget, we talked about this in class for those that were in the week of the 7th of September. We talked about how at the top of the cliff as well we have weathering occurring. Weathering, which also weakens the cliff from the top, which adds to the base of the cliff activities that erosion is carrying out. These are all the 4 forms of erosion together in one diagram. So remember that hydraulic action or hydraulic pressure is to do with air being forced into the cracks, not water. So the waves pound against the cliff where there are cracks, and because they are pounding, they push air into cracks that are already there in the rock. So remember, if you link that back to the rock structure, if you have rocks with cracks in, hydraulic action is going to be more successful because it can push air into those cracks. So when it gets pushed into those cracks, it expands. When it expands, it pushes the rock out of the way and the rock gradually crumbles out of the rock. Abrasion, that's supposed to symbolise a rock being thrown out the coast. It could be pebbles on a shingly beach. These look like enormous boulders on this diagram, but let's think of them as pebbles being thrown at the cliff, which clearly will chip away gradually at that cliff face. Solution, corrosion, we basically got that seawater chemistry eroding, generally speaking, at alkaline rocks like limescale. And then we've got attrition, where the rocks bang against each other with the movement of the waves and wear each other down, much like pebbles in a river. And also when these rocks bang against each other, they also bang into the base of the cliff and scour. Here's some wave scouring. As the waves come in, those shingle pebbles are moved against each other and become more rounded, but also they scour away at the base of this cliff. So remember, it's sort of the 2 things go hand in hand. You can't just talk about the 4 types of erosion without taking into consideration the other factors that also come into play. So the rate and type of erosion depend on the type of wave, i.e. destructive or constructive, and the characteristics of a particular coastline, i.e. is it tall cliffs, is it discordant with headlands and bays, is it resistant material, or is it softer rock? And most erosion happens during winter storms, so most of the erosion that happens on the coastlines happens in the winter when fetch is bigger, fetch isn't bigger, fetch is the same, but the wind is stronger, so the waves are stronger. Plus also you have storms, which increase the effect of those waves. Hydraulic action and abrasion are the most powerful erosive styles because they're the most sort of dramatic, really. But they do depend on weaknesses in the rock, e.g. cracks, joints, bedding planes, I should say planes, not planed, sorry, and faults. Plus the rock type, remember whether it's a soft rock like sandstone or a hard rock like limestone. Remember that waves refract around headlands, which also increases erosion, and erosion is generally fastest where the rocks are weakest for whatever reason. So remember Holderness, maybe from your GCSE geography, Hapesbury, which you've looked at in a case study in lesson 5, and the Dorset coastline where we have that softer rock behind the Portland stone in Lulworth Cove, for example. So you should have a look at the next few slides that are in the video. So what coastal process is this? So pause the video and have a guess what type of coastal erosion is this. That's right, that is abrasion, I'm hoping. Corrasion or abrasion, thank the Lord, yes. Okay, this next one, what is this meant to symbolise? So pause the video again and make sure you know what the type that is. Hopefully you were right that you said it was corrosion or solution. This type of erosion is what? That's right, it's hydraulic pressure or hydraulic action. And finally, what is this coastal process? Well done, that's attrition. The pebbles have become rounded due to being continually rubbed against each other by the power of the waves and thrown at the cliff base, thus eroding this cliff, so it's fallen down at this point. So that concludes this lecture. It's very short. We'll do a little bit of work in class on these 4 main types of erosion, but not too much because it is quite straightforward, and most people have done this for GCSE geography.